all physical separation techniques. So what that means is that in order to separate something physically, it has to be physically combined. So these are all the ways that we can separate mixtures, because mixtures are two or more substances that are physically combined. Okay, so what's important to know is kind of the basics of each technique and what kind of solution you would use or would separate using that one. So our first one is evaporation. All right, it's used to separate homogeneous mixtures, typically where we have a solid dissolved in a liquid. So for example, salt and water. You can boil the water off and you're just left with the salt. Okay guys, so this separation technique is evaporation. And so I've got this lovely jar of evaporating dish, and it's got water and salt in it. So basically in this separating technique, I'm going to stick it on a filter plate. Eventually it's going to boil. As it boils, the water will evaporate and we'll be left with just the salt. Okay, so you can see it's starting to boil, and you can kind of already see around the sides that there's some salt forming on the sides. Okay, so after it's all done, you can see we're just left with salt and there is no water. Okay, our next one is manual separation. Guys, manual separating is for heterogeneous mixtures, and typically it's where we can separate it based just like from visual appearance. So size, shape, color, texture. It's like for me, I don't like raisins in my trail mix, so I would pull out all the raisins, and I can pull them out because they look different. Okay guys, our next separation technique is manual separation. And in manual separation, the chunks are big enough that I can separate them based on like size or appearance. So for example, in this one, I can see my zinc chunks. So they're pretty easy to pull out of the sand just because, they're big and they're easy to pull out. So that's manual separation. Okay. Next would be magnetism. And magnetism is once again for heterogeneous mixtures. And in these, one of them needs to be magnetic, the other needs to be non-magnetic. And I can just basically use a magnet, put the magnet in there, and then pull out my metal. Typically it's like iron. Most of the time, pull out my iron, and then I'm left with just the non-magnetic substance. Okay guys, this next technique is magnetism. So here I have a mixture of iron and copper sulfate, I believe. Yes, copper sulfate. So the iron is going to be magnetic while the copper sulfate is not. So I can just use a magnet. All right, I kind of have to shake my magnet to get all the copper sulfate out, but the magnet should pull out the iron chunks while leaving this copper sulfate behind. So you can kind of already see that a lot of my iron is gone. So again, can just use a magnet to get out all my iron. And then our next one is chromatography. So chromatography is used to separate homogeneous mixtures, and it's going to be inks or dyes. So really the only place we use it in chemistry is in inks or dyes. Biology actually uses this one a little bit to separate out pigments and like leaves and things like that. This is actually how you can find chlorophyll in leaves is that you can separate it out, the pigments out in the leaves, but it's based on differences in rates of travel of liquid. So the heavier a dye or a pigment is, the less far it's going to travel, where the lighter it is, the further it's going to travel. So this is chromatography. Okay guys, and this separation technique is chromatography. So in chromatography, it's for separation of dyes. So you can see right here, I just have some black ink on my piece of paper, and what's going to happen is this water is going to travel up my paper towel into my chromatography paper there, and it's going to carry the dyes with it. And the dyes that are heavier are going to travel less far, while the dyes that are lighter are going to travel farther. And so we'll see that separation of those dyes. So that's chromatography. Okay. Then we have filtration. So filtration is used to separate heterogeneous mixtures. It's based on differences in size and solubility. So this would be where we separated something that is not soluble or will not dissolve in a solute or like in water. So for example, sand and water. Sand will not dissolve in water, so it's got those two separate layers, and I can pour it through a filter and it'll leave the sand and my water will travel through the filter and it's left there then. Okay guys, so in this one, what's going on is I've poured some just water and sand mixture into this flask, and what's happening is I have a filter paper, and so the water is passing through the filter and the sand is collecting at the top. So I'm going to show you guys. So you can kind of see some of my sand up top, and then my water passes through the filter, and so this is filtration, typically used to separate a solid and a liquid. When the solid isn't dissolved in the liquid, it can pass through the filter paper while my solid will get trapped. So you can see hopefully a better view. Pouring water out. There's my sand up top, and then my water is down below. So that's filtration. Okay, next we have distillation. Distillation is used to separate homogeneous mixtures of liquids. So it has to be liquids. And in distillation, they're separated based on differences in boiling point. So typically one's going to boil at a much lower temperature, and so we'll cause it to boil and basically catch, like have tubes that have that the gas that is traveling from it being boiled, the steam, I guess, that's traveling from it being boiled, and then we'll condense it in like another area. So differences in boiling point. So like alcohol and water. Alcohol has a much lower boiling point. And then this next one is centrifuge separation. This is used to separate a solid from a liquid, and it's based on the density of the solid. So what happens in centrifuge separation is basically we have these little vials that we put in the centrifuge. It spins it really, really fast, which causes our solid to settle down to the bottom. Then you're able to take it off, and typically we just decant off the liquid, which just means we take a pipette and basically squeegee off the liquid on top of our solution. Okay guys, so this is a centrifuge, and a centrifuge is something we can use to separate out a solid from a liquid, or just things that have different densities. So I can put my solution into my centrifuge, and I have to put another one in. So this one is the solution that we're actually going to be separating, and then this one is just being put in there to balance it. Turn my centrifuge on. It spins really, really fast. You just need to let it go for a few seconds. Let it stop. And then you can see, guys, that now what was like my solution is now separated with the solid at the bottom and the liquid on the top. And yeah, and so I can actually like squeeze, pipette off the liquid or pour off the liquid to just be left with the solid. So that's a centrifuge. And then last but not least, we have our condensing tower. This is used to, again, separate a mixture, and this one can be used for homogeneous or heterogeneous. And again, it's also based on boiling point differences here, but the real place that you would use condensing towers is in like crude oil and oil separation. Okay, so use your notes now to fill out this chart about which separation technique you would use for each of these scenarios. Pause your video, fill out this chart, and then when you're ready to go over it, restart your video. Okay, let's go over them. So for our first one, it says to obtain drinking water from muddy water. So the mud won't dissolve in the water, and it's quite a bit bigger than our water, so we will use filtration there. Ooh, misspelled it. Filtration there, and that you can pass it through a filter, and that'll leave the mud, and the water then will pass through. Then to separate petrol from crude oil, guys, we use a condensing tower there because the petrol has a different boiling point, and so it's able to boil that off, and you're left with the like gross stuff. I don't know. To remove leaves from a swimming pool, I said manual separation just because you can pick the leaves out pretty easily. I know a lot of people like use a net, so you might call that filtration as well, but I think it's manual separation. And then the last one is to obtain pure sugar from a solution. So that's evaporation. You can put the sugar in like a pan, the sugar water in a pan, boil it off, the water will go away and the sugar will be left. And then the last one, to determine whether the coloring in a fruit juice is a single substance or a mix of substances, would be chromatography, because we're seeing the separation there. All right. Hope this was helpful.